Hello everyone. Today we're going to talk about model registry, ML deployment, and how to make it happen using open source tools and specifically Git and GitHub, all the stuff from Git and GitOps ecosystem. A little bit about myself. I was a data scientist at Microsoft, Bing, for almost 5 years. And later I created an open source tool, data version controller, DVC. Is anyone familiar with DVC? All right, a few folks in the team in here. DVC is an open source tool for managing data, ML experiments, and now later we created a company, Iterative in San Francisco, and we built tools to automate machine learning process. One part is DVC, of course. The second one is CML, continuous machine learning, and we built Studio on top, kind of to incorporate collaboration scenarios and enterprise scenarios on top of our open source tools. So the idea in our tool set is we build tools on top of software development stack, on top of your IDE, such as VS Code, on top of Git and GitHub and CI/CD. So because we see that this conversion of the machine learning and software engineering. We have thousands and thousands of open source users of the tools, but when we automate their processes with our open source tools. But when it comes down to the clients, when we can see how the tools actually can help them to build their process, to build efficient processes. We try to evaluate maturity levels of their teams to understand better what tools can help them the most. Because the reality in the industry today is every tool builder, including us, they are focusing on super advanced scenarios, like the most mature levels. And then some teams are ready for those kind of tools and workflow, but the others are not. And it's better to understand what is the level of the team and what are the next better next step for them, instead of jumping to the later level, to the fourth level right away. So and how we do this, we usually ask simple questions. In the context of model deployment, we can ask how many ML models do you have in production right now? And how much time it will take to figure this out. And believe it or not, many companies, many leaders cannot answer this question, such a simple question. Or, what if your model in production doesn't work, doesn't perform as good as you expected? How much time it will take you to revert to the previous model? How fast you can find your repository? How fast you can find the right version of the code, right version of the data that you use to for this model. And again, some companies can say, hey, there's a Jamie, she knows how to do this, but this is the only information they have. The other companies have a repository, but this is kind of the foundation for the ML deployment process. If you cannot answer those questions, you're probably not ready to implement the more advanced technologies such as model registry and etc. And in this way, we kind of give scores, maturity level of the team on the different areas, like how they train model, how they collaborate together and decide between the team, how they deploy their models. And the goal is to get to the next level, not to jump from level 1 to level 4. It might take, I don't know, a year or 2 years, but how to get to the next level. And in majority of these cases, it comes down to how team organize the process, how team can use the tools that they already have. And majority of the team already have GitHub, but they don't use those efficiently. Don't use those in ML setting because it's most special. And it takes some effort to figure out how to do this properly. So we built a model registry on top of Git. I will tell more about this, but in general, I believe you're familiar with the idea of model registry. It's kind of one place where you have a list of all the models, what is in production, what is not in production, who was working on these models, when the deployment was happening, and so forth and so on. We are trying to use Git functionality as much as possible. So, for example, in the list of models that you see on the screen, these production statuses came from Git tag. And this is a usual pattern that people use in software development. We just adapted this idea to the machine learning world. And the GitHub or GitLab can become a central source of truth for your model deployment system, for basically your model registry. So GitHub has a tags, and these Git tags can show what exactly is happening in your production settings, right? What is deployed, what is not, when this deployment will happen, and so on and so on. So you don't even need like a special system to track these statuses. You can go to your GitHub, click to tags, and see who assigned the latest production tag, when it was happening, what commit message the person put while in the deployment. So this information can be used, and it helps the team to collaborate in the model registry settings. In addition to the kind of basic model registry functionality, like, okay, what is in production, what is not, what kind of models we have, this approach solves a few more problems that a traditional model registry cannot. One of those is a connection between your code and data, so basically the image, right? If model fails, if model is not performing well, how to find a right repository, right commit of the model. In a usual model registry settings, you're supposed to provide some like checksum, right? Checksum from your repository, like here, right? D1, 9C, something. But when you look at the model registry in a majority of the company, you will see that this information is not an actual one. For example, you might have like a one model in production with a checksum, like 43A, and previous model in production with the same checksum, and the model from the last month with the same checksum. So which means in reality you don't have a connection, you don't have an image. But when you use like a Git tags, there's no way you can beat this information, right? Because the kind of Git flow, Git workflow pushes you to do this, to commit this right here. The next set of problem is usual model registry, like not Git-based model registry. It's disconnect between your team, ML team, who does the deployment of the ML models, and the team of application team or software team. For example, you have an application which you use some models inside, and usually the software team has a special deployment process. You see, that's usually based on GitOps practices, right? So they commit their code, they put like a Git tag, it goes to CI/CD, CI/CD does the deployment, and so forth and so on. While ML model is separate because ML registry has special API and so forth and so on. And at the end of the day, the team ends up with two technology stacks for deployment, right? One for application deployment, and second one for model deployment. And you have kind of like a wall between those teams. They have a different lifecycle, different process, and that's a root cause of multiple problems. If you use a regular GitOps approach, of course, this problem disappears. You assign this like Git tags to your models, you commit your models, your code, you assign Git tags, and it establishes the same kind of workflow for both for engineers as well as the software developers. And this model, the need of in a centralized place, the model registry kind of disappears because the Git plays the role of becomes a single source of truth for your deployment statuses. So you can say, so right, you are saying that if we use Git tags in our system, we can simplify the deployment process. But it's kind of like a straightforward idea, like why most of the people don't use this, right? The problem is machine learning is a bit complicated, and Git tags it's only the first step, the foundation to do this. So first you start committing code that goes at least to production, not necessarily everything, right? You probably don't want to commit like every single model you have, especially every single experiment. But if model goes to production, it's committed, and the tags are associated with the model, it's a good foundation for the next steps. The step of CI/CD, which can recognize the tag, production, not production, and do like a proper model deployment. And there is a few more caveats, very specific for machine learning. For example, the first problem is the size of the models. So you don't want to commit your model in the Git repository, right? And when you are saying that you need to assign a tag for your model, I don't mean that you have a model repository, right? Model usually lives in your S3 storage or GCP or somewhere in the cloud. But there is a few techniques how to solve this, right? You can just provide some link in your meta file. You can use DVC to manage large data files. So there is some tricks. Some people work with a monorepo situation when they have, let's say, 10 different models, and when deployment is happening, they don't want to redeploy the whole 10, right? To find like a huge computer vision problems that will work in cascade to answer like one situation. But you need like a regular management around the models, and that's also possible. So to solve this problem, we built a new open source project which is called Iterative, and it helps you to basically build model registry on top of your Git repository. So you can see this like command which gives you like the exact model registry table, right? The models have, what is the version, the latest version, what is the history, what is in production, what is in others environments. And the cool part is that all this information came from Git repository. So there are no services attached, there are no anything special, so all is in your history with lineage, with authors, timestamps, and so far and so on. So, yeah, in addition to this open source code, of course, we have a SaaS, which gives you like, more visualization in model registry. It's needed when you have a team, when you have like 100 repositories and not like 1, 2, or 3. There is a VS Code extension which helps you kind of get the more developer experience. But the interesting part is like how those are implemented. Those are implemented on top of regular Git with some meta information, meta files, and this is a well-known approach which is called infrastructure as a code. In this case, it's like we are building model registry as a code, if you will. So that's kind of like a technical detail, like how it is implemented. So from a user point of view, it might be not too important, but that's how it works. So the side effect of using GitOps as a model registry is very interesting because by putting all the information to Git, it forces you not to just manage your models properly, but also to collaborate with your source code properly, right? In this way, from maturity level point of view, you are not only improve your level of maturity in deployment area, you also improve your maturity level as a collaboration, as a team. How your teammates work together with each other, how your team collaborates with your deployment team, or maybe IT ops or DevOps teams. So that's an interesting side effect of using existing tools that you already have. So thank you for your attention, and let's build efficient teams in machine learning space. So open for the questions.
The way you're demonstrating the second phase, you get going with this on my own, just like checking out from Git, and then if I want to have the additional user experience that comes.
Yes, exactly. We built all our tools this way, so if it's needed like for developers, right, for collaboration with small teams, so like for free, you need like more collaboration, like it's SaaS, UI and stuff.
So your case is basically found just before the deployment, right? So like people have different practices of putting the model into the deployment. So like how are you integrating the different tools? Because some teams might be using the platform like Databricks, SageMaker kind of a thing. Some people are just building in-house kind of solutions.
Integration with another tools, do you mean this ML sorting systems, right?
Yes.
Yeah. So that's a good question. So in this model registry part, we do care about CI part of CI/CD process. So CI/CD part, right? It's not there. So you define your CD process. So CI/CD is like a continuous integration, continuous delivery, right? So we do the integration, but in the CI/CD script, right? In the GitHub action, so with CI/CD, you define how to deploy. It might be like some push to the SageMaker, right, to some specific bucket. It can be like some communication through API with like Slack or something else. So, but that's like what you can define.
So, like, is there any integration from your side to such kind of a development platform, or people can just see like what is the latest model for a particular problem, and then they have to go to a different tool and use that to provide?
Well, if you are talking about the monitoring part,
Not a monitoring part, like even a deployment part. So like suppose I build a fraud detection model and this is and I do a lot of iteration. Now there's a staging model, then there's a latest model, right? And I can have a view of the staging and the latest model on the platform. But now if I have to deploy the latest model into the production, then do I need to leave your platform and then hit another platform and start to bring it up? Is that how the things will work?
If I understand the question correctly, so usually you do like kind of like your trigger CI/CD, right? By like assigning the tags. We visualize the state of the tag, like what goes to the production. That's I think you're right. But then when CI/CD triggers, this is like you define like what to do, like what does it mean to do the deployment to production, right? And in this sense, it's flexible because the CI/CD process is super flexible, right? So you define like how you do deployment. What does it mean to deploy to production? What does it mean to roll out the whole version, and so far and so forth. So, but in some cases, deployment is way more complicated, right? You know this. So in some system, you say I have model in production. It means it might have like zero traffic, right? So this is like area of another type of system. But our job from a registry point of view to deliver to production, and then the production system decides like how to allocate traffic, how to do the actual sorting. Any other questions?
Can you comment on how your model registry would integrate with like an artifact rate or like deployment binaries? Also, if you wouldn't mind integrating something that compartmentalize all artifacts, secure access to them.
So that's a question about like artifacts management, like how you do like artifacts management, right? And different teams have different answers. So in our case, we do support integration with DVC, which does support like around 10 different tools. Artifact is not there yet, but it will be soon. But it can be done by kind of yourself, right? CI/CD side. If you have many information about artifact, so it might be enough to do the actual CD process, right? When CI is in place.